Hello.
Hi, Praveen.
Hello.
Hi,
Sudeep?
Praveen. Yeah, I can hear you.
Yeah. Okay. No one is here yet. Someone joined. Athar joined.
Last lecture video is uploaded or?
Yes.
It is uploaded, but I think it's uploaded for use. So something weird happened a few days back. The other guys, other batch, their video was when I uploaded. It was like reported by YouTube that there is some invalid. Okay. So again, looks like Nitesh won't be here, so we'll start. But last lecture video is uploaded. Okay, just give me one more minute.
Praveen, I'm not able to hear you.
Can you hear me now? Vasant?
Hello?
Yes, Vasant, can you hear me?
Yeah, now I can hear you.
Give me a second. Okay, did you guys try that question? Is height balanced? Anyone?
No, I haven't.
Okay. Let's start with that only, because that is important for us to go ahead. Okay, so we did find the number of nodes. We did find the height. Now third question is height balanced? And
Did you share the screen?
Yeah, I'll say it. Just give me some time.
Okay.
Meanwhile, you can still you remember the question is height balanced. Try to solve that question. Give me code for. Someone has submitted some code. Is that Subhadeep? You shared some code that is about anagram and not about. Yeah. Okay. Okay. So let's first try this is height balanced only. Okay. I'll share the screen in 2 minutes. But you first try is height balanced again.
Praveen, for height balance, it was like left sub-tree and right sub-tree height should be less than equal to 1.
Your voice is too low. Can you speak a little louder or make sure your mic is okay?
So for height balance, it will be like the difference between height will be left sub-tree and right sub-tree will be 1.
0 or 1, yes. 0 or 1.
less than equal to 1.
Less than equal to 1, yes. So you have this code, count nodes, you have this code, calculate height of the tree, and then we were discussing is height balanced. Yes, so someone can tell me about the approach at least, what you're trying to do.
So first we'll calculate the left height and the right height, like the previous code in L underscore height and R underscore height.
Okay. Can you
Then
just
I
repeat?
yeah. So in L underscore height and R underscore height,
Mm-hmm.
and then I will find the difference between L height and R height. It will be less than equal to 1.
Mm-hmm.
Then we need to
Return.
check again that left subtree is balanced and right subtree is balanced by
Yes.
recursively.
Okay. So you are on the right track. So are you guys writing where you are in chat or in your
Notepad.
editor? Notepad. Yeah, try to write in some editor. Yes. Okay, send me at least something so that I can discuss. Anyone?
Just a second, bro. Just a second.
Yeah.
So we have to check step by step, right? Like we cannot directly check the whole left height and whole right height and then check. We have to check one step, like one level at a time. And for every level, it should be less than one, the difference.
Not for every level, for every node. I mean,
For every node.
for every node, the property should be satisfied. Yes, for every node.
Okay.
Okay. So there's a code submitted by Subhadeep. Let's, if you people have written, you can also share. Otherwise, let's look at his code. Okay. So if root is equal to null, return 0. Why return 0? 0 means false, na?
Yes,
Subhadeep?
yes.
So why do you want to return 0 for a null root? Like you can return true, na?
Yeah.
If there is,
Yeah, I
return,
did integer return. Actually,
should be no, should
yeah,
it be
yeah.
0? Should be 1.
It will be 1.
Yeah. Okay, so now we have left height. Now we have right height. Okay, we have both things calculated by using our, what is this? This is recursively calling balance height.
Sorry,
That should
height
be
of the
different. Height.
tree. Height of the tree.
Huh?
Height of the tree. Height of the tree.
Okay, calling
That is
height of the
different
tree
method.
for both the subtree, and we have the height of both the trees. Now using those two values, what we are trying to do is we are checking the difference. If the difference is less than or equal to 1, actually should be modulus, I mean absolute value, and not, if absolute value of L height minus R height is
Less than 1.
yes, then do it again for left subtree, and do it again for right subtree, and call this recursively again, and then return. No, don't return after this. What? Just call and forget what you do. You should store some values, or return this only. So this is like writing code is a problem. See, there are two things. One is solving this question, understanding the algorithm. Or second is writing code. If you cannot write, like if you don't, you have to understand this thing. What is there is no meaning of this. This is like a little bit meaningless.
Okay. It will be in the if block.
Yes, there's something called if or if else will do that. Otherwise, better thing just smart code is if else, just return this. I mean, if this equal to true, then return true. Doesn't make sense. No, this simple thing. They return this. So this is good. We have the height calculated. We're using both the values. We are checking if the absolute value is less than or equal to 1. We return. We call recursively on the left subtree. We call recursively on the right subtree, and then we have. Yes, this is correct. Now, what is the time complexity?
N square.
N square. Can you explain how?
Yeah. So, firstly, it is for height check. There is a height check.
Yes.
For that, it will be N, and there is a recursion of balance of height tree. For that, it will be N.
Mm-hmm.
Then 2 times.
Okay. Yes. So the complexity is order of n square. So this is what I was talking about in the last class. That okay, nothing. So now we want to improve. Can we do it in less time?
Yeah. Finally, what we are returning?
What?
Finally, are we returning 0 or are we returning 1? Means if everything goes fine, then we are returning 1, right?
Yes.
Yes. True means 1. Yes.
But when it will fail.
Yeah. This is going to be correct. I call it false only. I don't want to take this. Okay. So we want to improve the time complexity now. So one thing, how do you think about improving? So what is happening is we are recalculating the height every time. So for every node, we first calculate the height, which takes order of like this takes n time, this takes n time, and then we do a recursion for both the nodes. So we have already, and this height calculation is something when we start from the root, we would do for the root, and we do for left side, we do the right side, and when we call this recursive this method recursively on the left side, we will call this method again. So if somewhere we can store this, or we can do something like storing this somewhere, or reusing the same thing, then we will not have to like recalculate this. We can use we don't have the catch here is I don't want to recalculate this every time I go to every node. That's the catch here. So how can I avoid calculating this?
So can you repeat what did you say? So we had to store somewhere, like for every node we had to store somewhere the height.
I'm not saying we have to store somewhere. I'm just saying key we want to avoid this height calculation every time. So what is happening if we're starting from the root? So let me draw on again for something for you. So if this is a tree and we are calling this is height balanced recursively on the both left child and right child, what we do is we first calculate the height of the left subtree, then we calculate the height of the right subtree, and then we using those two values we decide whether it is balanced or not. Now, so let's come. Suppose we started our recursion from here, okay, root node. Now, for this root node, we calculated height here, and we calculated height here, okay. So this height calculation is for whole subtree, which takes order of n, or we can say order of n by 2. And similarly, this height calculation of here will also take order of n by 2. Now, when we call recursively is height balanced again on this left subtree, this will call recursively this will call the left height calculate left height once again on this subtree, which was already called once before only when we called this is balanced on the root. So what I want to say is this method, this height tree, this gets called on every node multiple times. Yes. So can we avoid that? I mean, the ways to avoid would be obviously I use the word store. If you can store or if you can do something that we do not have to recalculate the height for every node. Okay. By the way, this is a very standard type of question, and this logic is used in multiple places, not just here. There will be many questions which will be like this. You want to take a decision on every node, and that decision depends on something else of every node, and that something else you calculate recursively and repeatedly. So we would like to we don't want to calculate that repeatedly, so we would do something special. That something special which we'll do here will be used at multiple other places as well, not just here. There will be a few more places which will use the same kind of solution. This is kind of a question which will be repeated, and the solution will also be repeated. Not solution, but the type of solution will be repeated. So this is an important question, by the way.
We have to store the height.
Store the
height. Like
okay.
This called height tree root left root right. We can reduce this, then will it work?
Come again.
So here like height tree is order of n, correct? And this recursion is order of n. So if we can reduce any of one, then the recursion will reduce. Sorry, n square will reduce to n.
Okay.
But we cannot remove the recursion itself, so we need to remove that height tree, and we need to store that somewhere for sure.
Yes.
Yeah, probably here we need to use any node functionality or what means like linked list type node. In the node we need to save something.
In the node we need to save something.
I'm just asking.
Yeah, so that might be a solution that we change the node and we store the height whenever we calculate for the first time, and whenever that height gets called again, if it's already calculated, don't calculate again. Just use the already stored value. That might work here. That will be a good solution. Are you saying the same thing?
Yes.
Vasant?
Yes. Yes,
What is that? What is that?
Vasant?
Yes, can you hear me?
Hey, sorry, Yeah, we were discussing. So you were saying that you would store the height of the node in every node while calculating for the first time, and now if we get the recursive height calculation again on the same node, and if you already calculated, don't calculate again, just return the same height. Are you saying that thing?
Yes, Praveen.
Yes, that. So everyone understood what you're saying. That this we'll have to change this L of height of tree method. This L of height of tree, this L of height of tree will be something like this method. So we will have to change the node structure, and while calculation, instead of just returning, we'll also change the node. Okay, root dot height equal to this before returning. Okay, so now what we'll do. So what he's trying to say is we'll store the value, and next time when we do a recursive call on the same node for the height, we don't do a recursion, we just return the whatever already okay. That will help, and that will also reduce the complexity from order of n square to order of n. That is also correct. Do you understand what we just did, Atharv?
Yeah, I understood that we need to store, but how for every node I need to? I'm not
Yes.
sure.
So just think about this int calculate tree height of the tree for the
Right.
root. Okay, this is for one node. Now, what if I give you a task to calculate the height of all the tree, or instead of calculate, store the height of all the nodes in the node itself. Suppose node has a one more instance variable called height. So what if given a tree, store the height of all the tree in its node? How will you do that?
So we will traverse each and every node, and once we traverse, we will calculate the height and we'll store somewhere.
Yes. So bad approach would be that you go to each node while traversing, and then call this method, this calculate height for each node. This is a bad way.
Okay.
Why bad way? Because what you're doing is you are going to each node, and then for each node you call me recursively. Then it will be order of n square. But you already are traversing. So while traversing only, when you reach the node, you already are calculating which you're returning. So just store also before you return this.
Mhm.
Before you return this thing, store also, and then return. Okay. So that's what I'm trying to say is instead of so not instead of, but yes. So Vasant's solution is you just change the structure of the node, and then this method will take care of this method. This recursive method will take care that it does not get called to the leaf node every time. Every time we call this, only for the first time it gets called to leaf till the leaf. For the next time, it won't get called till the next leaf only. It will be just stopped. It will stop at the point where it was already called. So for the first time, when you start from the root, when we start from the root, we call recursively on the left node. We call recursively on the right node. Sorry, not recursively, but we calculate height of the left subtree. We calculate height of the right subtree. Now these two methods, which was called for the first time, these two methods, this method and this method, these two were called for the first time for the root. At that point of time, we would traverse all the nodes, not just this. We would traverse all the nodes. Now that traversal was like this method, calculate height of the tree.
Right.
That this will take care that because this is also going recursively to all the nodes. This is also going recursively to all the nodes. So this will take care that I'm using the height of the left subtree, using the height of the right subtree. I'm returning it to the parent call, but before returning the parent call, I've also stored the root dot height equal to whatever I calculated.
Mm-hmm.
So now what will happen for the first? This will get called only once. These two call will happen lots of recursion only for the first time. From next time, all the recursion will stop at the here terminal here one condition only. If root is not, equal to null, else if root dot height is not equal to minus or something like that, which is like okay. So then return root dot height. So if it is already calculated, then just return. Otherwise, do a recursion. So for the first time these recursion will happen. For the next time there won't be any recursion. Why? Because we have already calculated height of all the roots. Hence we'll have this thing calculated for every node, and hence we just return this. There won't be any recursion. So for the first loop, so for the first main recursion, this and this, the complexity of this and the complexity of this will be order of n by 2 and n by 2. But after that, all the calls will just constant time and constant time. Hence, total time complexity will be n and not n square. Okay, now you understand this. But my point is, we cannot change the structure of the node. We cannot store anything in the node. Then what will you do? Also, I'll put this concept as well. You cannot even use extra space. Like you cannot use one more hash map where you will store this node and then hide there. You can't do all those things. Okay. So we have to check whether both the subtree is height balanced. What are two things we have to check? Just two things. Like at every node, we have to decide two things. Is my left subtree height balanced? Is my right subtree height balanced? And so the two things: is my left subtree height balanced and my right subtree height balanced? And this also, there are three conditions which has to satisfy for this to be a height balanced tree. So what if is height balanced root dot left, this is one thing, is height balanced root dot right, this is another thing. If both of them, like is left height balanced, is right height balanced, both things. If now we have to check if these two are true, and height also. Now height, we have to calculate a height. That is another headache. I don't want to calculate height once again, because if I can do something like, if I can use this method only, to calculate the height somehow, because these two are two recursive call which will go through all the nodes. Can't I use this method only? So there are two ways to solve this. One way is either you return 0 for false, sorry, -1 either you return -1 or you return if it is height, then return the height, otherwise return -1. What I'm trying to think is, depending upon the return type only, but this is Boolean, true and false. Okay, leave it. So if this was int, can we do it with the int? If it is height balanced, then I'll return the height. If it is not height balanced, then I'll return -1. So I can modify this method a little bit, and I can return this method. This method will return me height only. If it is height balanced, then I'll return height. Otherwise, I'll return -1. Okay, then I can use that thing. LH equal to is height balanced and RH equal to is height balanced. So these two are recursive call, and they are returning integer, either -1 or height. If it returns -1, then it means it is not height balanced. If it returns height, then it means it means that it is height balanced. So if LH is more than equal to 0 and RH is also more than equal to 0, then return max of LH comma RH plus 1, else return -1. do you see? So same method, same recursion. I'm using like tree only. Sorry, I'm using like calculate height tree only. Instead of returning the height every time, I'm also deciding two things. Only if the height left is right balance and right balance, then only I'm returning height. Otherwise, I'm returning -1. So the moment I find first -1, I will return false. So now this method is doing two things at a single point of time, in a single recursion only. So do you understand how I changed my recursion to take two decision, like to do two calculation at single traversal? Vasant, Atharu, Subhadeep, do you think this will work?
Yeah, Praveen, is
Yes.
height balanced, right? That is the same function we are calling.
Yes.
So that means so tell me one thing here. Is height balanced, right? So you
Yes.
mean to say this is the same function we are calling again? Means same function means int is balance height tree. Same thing we are calling. So
Yes. Yes.
how it is going to return? Because if you see the condition LH greater than, okay, initially we need to assign LH equal to 0 and RH equal to 0, I think, right?
What?
Initially LH and RH should be 0. Initialization, I'm telling, in the above somewhere equal to 0, then
It is JavaScript, it is Ruby. Why are you worrying about?
no, otherwise if condition, it doesn't go if condition if you want to define proper.
Why would it be?
Otherwise
Tell
it
me
will
what
go
is
to
the
else condition, I think.
अच्छा ठीक है रूबी में कोई दिक्कत नहीं रूबी में ये 0 मान लेगा
Okay.
ठीक है
So yeah.
ठीक है ना so you have your LH calculated, you have your RH calculated.
So here we are taking maximum of LH comma RH. Okay.
Yes. Okay, Subhadeep, you got this?
Yeah, like
No?
here return max of LH and RH plus 1 means whatever is greater than I will return plus 1.
Yes, whichever is greater, just add 1 to it. This is what we did here, na? This 4 line.
Okay.
This
Okay.
4 line is equal to 1 line of mine.
Okay.
Means whenever it is going to -1 condition, when we can expect -1?
When can we expect -1? That is the question.
Yeah, I'm asking you like.
Yeah, sorry, that is missing, na? Wait a second, just a second. So if LH is more than equal to 0 and RH is more than equal to 0, and one more thing, sorry, absolute of LH minus RH, LH minus RH is the main thing to be measured only. Boolean equal to less than equal to 1. Otherwise, yeah. Is this okay now? See, so again I'm repeating one more time. So what we wanted to do is we wanted to do two things. One was height calculation, like this method solution. One was height calculation, and another was that even this height calculation was a recursive call. Even this is also a recursive method. And another was after we calculate the height doing the recursion, we are using those two values to do more recursion. After we I have kind of merged these two recursion in single call by changing the return of the return by changing the return type of the method. I have merged those two recursion single. This is returning the height as well as returning if it is height balanced or not. But but this is not possible every time. But in this question, we have been able to do that. That this method is returning -1 and positive and 0 to anything more than that. So if it is returning -1, then it means whatever height it is, I don't care about the height, but it is not balanced. So I don't care about the height. This method returns integer, and what does that value means? If it is -1, I don't care about the height. It is not balanced. If it is positive or 0, then it is height balanced, and with the height is equal to this. So that's what I have done with the method, and hence I've used those two recursively. So this will, and these two call, if you see, if these two call are exactly same as this old method which we write, this calculate height of a tree. Okay, forget about this logic right now, -1 and all. Just tell me, do you understand this thing easily? Very, very simple. This is very simple.
Yeah.
This is simple. Guys, this is simple. At least calculate height tree. You understood for the last one. Yeah. So now, what if I just wanted to change this method a little bit, and instead of returning height every time, I wanted to return return height only if it is balanced at that node, and return height if it is balanced, and return -1 if it is not balanced. Then how would this change? This will change a little bit. Return height. So return if L height, absolute of L height minus R height, is more than 1, then return -1. Don't return height. Else, do this, what you are doing earlier. So what this does, for this is like at one node, I want to check whether that node is height balanced or not, and I don't care about complete tree. I just care about whether this node is height balanced or not. If it is height balanced, then return the height. If it is not height balanced, then return -1. This is what this code does. Now I've done this recursively for all of them. This is doing for recursively for all of them. Calculate the height using this method, and then using those two height, return the height if it is satisfied this property. Otherwise, return -1. So what is the confusion here? People, tell me, what is the line you're not able to understand?
So here, hello.
Yes.
Here you are checking that 3 conditions together, right? Is
Yes.
height and absolute value together.
Yes.
And if the return is true, then the height is balanced, correct?
What?
If the height is, if return is 2, 1 plus 1, then the
Yes.
height is balanced.
Yes. If the return is anything more than -1, like if it is 0 or positive, then it is height balanced tree. Otherwise, if return is -1, then it is not a height balanced tree.
Yeah. Then these codes are not required below side.
Yeah, that's not required. Yeah, it is not required. Oh, sorry, I confused because of this.
I was thinking that I have to check that also.
No, sorry. ठीक है. If you have not understood, actually, I was giving a solution here, but this kind of solution might not work in every question of this type. What I mean by question of this type? The question of this type means there will be a more question which will ask you to check if this tree satisfies some property, and that property should be satisfied at all the nodes. that kind of question, there will be lots of questions of this type. If this tree satisfies this property for all the nodes, so you what will do, you'll traverse all the nodes and then try to check for all the nodes. And while checking that for all the nodes, you'll have to do one more recursive call. Here we are doing one more recursive call to find the height. And those questions you might have to do something else. Okay, you might have to do something else. So you might end up doing this, calling that for each node, and you might end up calling height for each node. Then it will recursive call. So we can save that recursion by some trick here, which is like the trick here is when you're doing recursively, when you're traversing the node, which is how we are traversing, which we are traversing with this recursion only, by the way. When you are traversing through all the nodes, you like return the property plus you return whatever needed for the property at both the thing in the same variable. But this might not be possible in all the question. Your single variable you might not be able to. A single variable might not be able to contain both the things, like both the knowledge in single. What do you mean both the knowledge is like it might not be able to contain your result as well as like some more data. So what we can do is, instead of just having a LH, you can have an object. What object is like some output, which you can create one more output class, which will be height, HeightBST, and also the result, something like that. Now, when you call this recursion, you will not just return. You'll have to return this complete new object, which will be so whatever I'm doing is a little bit more complicated only. Now using these two, you can do something like out. Then you can do all your logic. If output L dot height is more than is minus this absolute check. So
Output
I have
dot
calculated.
result.
Yeah, just a minute. So you understand what I'm trying to do is,
Yeah,
I am
now it is much clear.
okay.
Now it's like we can see two different values, right?
Yes.
There it was like only in one value we are calculating both the things.
Okay. So actually, this is more clear and this is more repeatable as well. That solution cannot be repeated everywhere. If this is true for all these three things are true, then return a new object, output object with which is sum
Max
of
of
max of sum of these max of this plus 1 and comma true. Okay, whatever. This is max of. Okay, you can do what you want to do. Okay, you can do this. Now this you understand easily.
Max of height, right? Both the heights.
Yeah, max of both this output of height, comma output of, let me write one.
Okay, okay.
output L output R.
Yeah.
Prevent here, why are you putting inside, like why are you creating object and sending this one?
I'll tell you. Because I did not want to do two recursion. So what I want to do, I want in single recursion, I want to return both the value. Now, what is that structure where I can store both the things? Or suppose tomorrow not both three things. I can there can be some question where we need to return three things. One is the result which we want to return, and other two is some other property which we calculated for each node. Like height, we might calculate something else for each node. I don't have a question right now, but I'm saying while checking this height balanced, we need to return some more property for us to take some decision. So that's why we created another object which has both the result as well as more properties. Suppose we had few more property we needed, property 1, property 2, something like that. So this solution which by the way what I'm giving is not the ideal solution still. This is something I have derived myself. I haven't seen this kind of solution anywhere. I'll come and discuss the solution which has been given everywhere, by the way. This is something I have found myself. Right? I thought of doing it myself. Someone left or what? Okay, anyways. So this solution is not the ideal solution. I haven't seen this in any book or any website. So my answer to your question, Vasant, is because we want to return more than one thing. So with the last solution which I gave, you were confused. In single variable, I was returning both the things, the height as well as true false. Height was the number and the true false was the sign. In single variable, I was returning both the things, but you people were a little bit confused. With this other object, I'm still returning two things, but in single object, and I'm not being clever. Like, okay, if the height is -1, then I'll think it is not balanced. If height is +1, then I'll think it is balanced. Those kind of smartness I'm not putting here. I'm simply I simply have two things, true, and I have this height as well. Output L, output R dot height. So long things are there. So
the same solution like previous. It's the same solution like previous. LH add H.
yes, this is same like that only. I have whatever we did here, calculate height, do recursively on left, do recursively on right, instead, and then sorry, this is something else. Oh, okay, and then we took the decision based on the output of these two. Output of this and output of this was needed to decide what should be the output of this main. Output of subtree, output of left subtree, and output of right tree was used to decide what is the output of the current node. I have used object to store two values, not just one. If this is clear, then I can give you an even better solution where you don't have to create these objects and all. You can, you won't even have to do this kind of. I mean, you might have to create object, by the way. If not, this is some other object. But let's now take another solution. I'll give you another solution now, last solution, which is. So what we want to do is we want to change this method a little bit. This solution is again from somewhere else I picked up. So whenever HeightBalanced or some property is come. So I'm changing this method little bit, and I am passing it some property. What I'll do is using this passed property, let me just write something for you. Property left is equals to some new property. I'll initialize two properties and then one more property I'll initialize, and I'll pass these two. I'll pass these two property again to my recursion. RIGST. So I'm writing property here because this is very common kind of question. You'll face this question again, where you'll have to pass some property and calculate that property in the recursion. So now using these two, let first I have my left property, I have my right property. So this is Boolean. So this is is L. This is in Boolean. So the return type is Boolean. So we always have to return Boolean only. So I'm saying this is L and this is R. So always think like this is recursion. So use the property of the recursion that you can always assume that this will be working. You also assume this is working. Whenever you write a recursive method, sometimes it becomes really complicated how to write a recursion. So whenever you're writing a recursion, use the property that whatever I'm going to write is HeightBalanced is balanced height tree. Okay. So whenever you call recursion, use the property that whatever you're writing is working. Hence it will work for your subtree as well. So don't hesitate in doing that. So just have written is L, which this will be Boolean, is HeightBalanced root dot left comma left, something I've passed. So since I'm writing a method which will work, so it will work for this recursion as well. Similarly, this will work for this. Now with these two working, I can easily say few things that if, again simple thing, if my left is balanced and is R is balanced, and if these two things are property, if these two things are true, and one more thing is true is if left property and right property, that now using this property, we are using this property. If, again simple thing, if ABS of left property dot height minus right property dot height is less than equal to 1, then return true. One more thing we have to do, by the way, we have to
calculate the height.
Yes, we have to calculate the height so that we can assume that this method, after calling this method, this was set somehow. I mean, we are using this absolute of left dot height. This is assuming this will be calculated. Hence, we will have to calculate. Let me just first this thing return false, this thing. And now what we have to do is, before returning only, we have to calculate the height of this node. So this current root dot, so I'm passing this prop which was passed to me initially, this prop dot height which was passed is equal to, we have to calculate this equal to max of So now we are doing two things. One is calculating the height. In previous solution which I gave, we were returning as well. In this solution, we're not returning. we are calculating the height and just storing it in the variable which was passed to me. Simple. And now, so this method is height balance. Is what you're doing is returning true and false, as well as setting this whatever property you pass, setting the property dot height as well. So now I can assume that I called is balanced on a left child with and we passed left, and I called this height balance for the right child and I passed right. Both of them would have returned true false and would also have calculated left dot height and right dot height, because what my method does is, this is what my method does. My method is recursively, whenever we call method, it sets the height of whatever I pass it to, whatever variable I pass to it. It sets the height of that variable, that property variable, and also returns true false. So assuming these two things it does properly, I'm assuming, yeah, this will be doing this for sure. This method will be doing it for sure. I can use this for my calculation of the height of the property I passed to it, and also I can return true false. Which is more complicated, this one or the previous one, the object sim, which is more simple and complicated for you guys?
I think the previous one was much simpler. The
Much
object.
simpler?
Yeah, Praveen, here I don't think so it works, I think, because again we are initializing left, right property. Always it is, I don't know, as per my knowledge, if you see above, again you declared property left, property right. I don't think it is going to, every time we are initializing.
Yeah, everything
always
will create a new object basically.
new object. So maybe the best way to do this one is a return itself, right? In the return true false, we need to return object any out there instead of returning true false.
No, I didn't get it. Coming where
See here in property dot height, you are calculating max of left dot height, comma right dot height plus 1. So
yes.
what it means, always assume it is created now, like above property left, property right. Always it is 0. Assume both left dot right, right dot right. Just we are adding and we are, yeah, that's it.
No,
nothing else. We are sending it back.
By the time I reach here, so when we slice, left dot height will be 0.
Yes.
And right dot height will be 0. Now
yes.
I call this recursively. This recursion will ensure that, so this is what pointer and all about. I have passed the object. So this, whatever it does, this will change the value of left dot height. It won't this method, if I do whatever I have passed the left object, so whatever I change internally in the object using this recursion, it would have changed the height, and hence I can use that height. Do you agree? Do you think this left dot height will not be changed by this method?
No, in the next call, what will happen? It will again create new property object, and then it will be passed again to the left and right height.
Yes, so that is recursive call. That is another level in the stack, and that will have its own left and right. So the current left, this is recursion. I'm not like this. You have to understand how recursion works. So for the first call, it created one left object and right object. Now this left object was passed to this. Okay. Now it might have called one more recursion, and that recursion would have initialized one more left, and that left was not same as this left. That left would another left. Let's suppose like left 1. This left won't be affected. So that left, and you're not even aware what happened to that left. This external, the first level is not even aware what is happening in my internal levels of recursion. I only care about my left, which I passed to you. I only care about, so this external call is only aware of, I passed your left, just set the property of left dot height. I don't care how do you do it. If you call recursively and if you create your own left, create with your own name and something, I don't care about your. So this is how recursion works. Whatever left gets initialized, that won't be visible here. This left will only be this what it was initialized. Okay.
Yeah, Praveen, here you written left dot height. Okay, left dot height and the right dot height. I'm not sure. I don't know, because Instead of creating object, we could send integer also. It works better because object, it's like every time it's okay. I got your point. Like each time whenever it goes, it creating new object. Okay, that means assume if we are at 50th level, it is going to create
You
50th
cannot,
object. That means count is 50.
you cannot, Vasant, you cannot send a simple integer
Hmm.
because that value won't be reflected. If I pass an integer here, if I pass it int left, if I pass int left equal to 0 and then use here, and then here I just set uh, what I prop equal to left comma right, something like this. This will not work. Why this will not work? Because this left, okay, so I'm commenting on this, I'm commenting on these two as well, and I'm trying to do what you said, and this will not work. Suppose this was not a property, but this was an integer only, and I passed these two integers in left and right. Now, if you try to access your left, do you think your left would have been updated here? What will your left will still be 0 here? It won't be anything. Whatever this method does to left, this is like pass by reference and pass by that thing. That those. So if you pass your left here, this left, whatever happens to this left internally, if you try to call it print your left here, it will print 0. Um, it won't print your change value. That's why I had to pass a class object and not simple variable. Or you could have used C and C++ where you could have passed, or you could just a second, or you could have used C and C++ where you could have passed a pointer, where you could have passed an integer pointer and then change that integer internally, change the integer value, and that could have worked. If you instead of class, since I was writing in Java, I have created an object and I'm passing the reference to the object, and whatever is happening to that object inside is getting reflected outside as well, because that I passed as a reference. So I'm changing the reference dot height. So that's why when I'm trying to access that object outside of this, after this recursion is over, that object has not changed at all, but inside that value has changed. So I can't do that with simple integer left and right. I can do this either with pointers in C or with passing by object. I cannot do this left or right simple.
Okay. Here my question is where we are assigning left dot right and the right dot right value. I got your point. I agreed for that one. Where we are assigning left dot right and right dot right at
Where
least,
are you
because every
No, you left dot height. You mean to ask where are you assigning left dot height?
means assigning somewhere we need to assign somewhere we have to return some values, so it should like prop dot height equal to maximum of something you have written. That's correct. Where we are assigning left dot right or right dot right, anywhere else are we assigning something? Because I'm not able to see. Okay, it is looping recursion is going on where we are, at least we need to change the value, right? Somewhere we need to change that value left dot right. We need to assign something where we are doing that one.
Okay, I'll try to make you understand in some other way. So what this method does is sets the property and returns true false. Okay, sets the property and return true false. Okay, okay. So if I call this is height balanced, if I call this is height balanced with initial property equal to some new property and node root equal to some root. We have these two things. Now I want to call this method for the first time. Okay, suppose I want to call my is height balanced for a root. I call this and I pass this initial property which was empty. Which the initial property dot height was not set yet. Okay, not set yet. Now I know my method which I'm going to write. What it will do, this will return true or false, because that's how I want to write it. That's how I want to write. And after this method is executed, the variable which I defined, this property which I defined, will also be set. This is how I have written, how I'm going to write. I have not written yet, but I'm going to write it. That after this method is called, it will return true and false, as well as this will set the height HeightGST to something. This is what I want my method to do. Okay. Now, so I initialize a property before. I had the root before. I called the method, and this method returned true, false. And also, after the method was done, when I checked the property, it should have changed property of initial property of height to something, because I passed the reference and I told that method change this reference dot height to something. I want you to change. This is what my method is doing. Now using this knowledge, okay. By the way, before I move ahead, can I do this or not? Can I pass a reference and can I expect that this method is capable of changing dot height of this property? Is it or not? Can this method do this? That I pass it up initial property, that is an object of this type of property class. Then can this method do? Is this method capable of changing the value of dot height? Vasant? Yes. If I do inside this method, I just simply do prop dot height equal to 2. That's it. Nothing else. Prop dot height equal to something. I just do this one. I do something, and then I suppose there is no other code. Simply I do this. Then if I try to call initial prop dot height, it will be 1. Hoga na? I can do this. Now assuming that this method is capable of doing two things. One is returning true and false. Another is setting the value of the property which I passed to it. It is capable of two things. I'm doing those two things only. So I'm doing two things. How I'm doing it, I will come later. How I'll do it, I'll come to that later. I'm doing property dot height equal to something, and then I'm returning true and false. Okay. Now I'm doing two things. One is returning and one is setting. Now you're saying, how do you know this? Left dot height would be set and right dot height be set. This is we know this because we know this. This is we know ना. हमने यहाँ पे किया यही तो हमने method बनाया हमने. Our method will be able to do this. It will be able to set. So this method, I passed it an empty property. There is one thing missing. Sorry, there is one thing missing. Dot.
Yeah, prop dot height
equal to 0. Sorry, that was missing. If this was the only confusion, so what my point is, I'm assuming that these two methods, which I have called recursive, had done its job properly. What does that mean? Had returned true false properly, and also has set the left properly and right properly, left dot height properly and right dot height properly. Now, and why I can assume this, because that's what my method does. Using the values of the recursion, it sets the property which was passed to it, and it uses that to it uses those two values to set the prop dot height and also returns. Can you think this way now? And when will this? So if you're not able to understand, you can try to draw a tree. You can try to draw a tree and small tree and try to run this one by one for each nodes. You might be able to get this that way if you're still not getting it. Vasant, ask me if you still have some confusion.
No, I'm just thinking. I'm just drawing tree and I'm just thinking myself.
Yeah, I'll get the chat. You can see that code only. Don't see what I'm writing here. Otherwise, you're confused. Just see. Meanwhile, I'm write a C code as well, so that you get even more clear what I'm going to do. Okay. Just look at that code right now for right now. Okay, so this is now C code. So what I'm doing here, so as I made clear that we cannot simply pass the height, because if I pass simply the height, then passing it to the recursion method and expecting that it will be changed in my next line, it won't happen, because that is passed by value and not to pass by reference. We want to pass the reference. So for us to pass the reference, either we create an object and pass the reference, or we use this C pointers method. So if you can see this code, what we did was we first started initialize to so this method is height balanced, which takes the root and takes the pointer to the height integer. Okay, now we have two integer LH and RH, which we needed. So I am passing those to, this is one simple condition. If root is equal, then height equal to 0, then return true, which is 1, and then star of height equal to 0. This is like object dot height equal to 0 only. This is a property which is simply we cannot since we cannot pass integer height, we had to pass pointer, and hence we're changing the value. You know what is star and all, people?
Yes.
Yeah. So what is star and what is and plus style in C? So star of height is equal to 0. This is what we. So by doing this, if this was called for a null node, this was setting after calling this method, we can expect that. So what was there before method? Before the method, there was int height equal to nothing or something, equal to 0, and there was this root. Now I passed these two to my method is balanced in this way. I passed the pointer, I passed is balanced, I passed the root, and I passed pointer to my height variable. So after this, I can surely expect that my star, my HEI would have changed, because this method does something. This method does star of height something. So that could have changed. I can expect this would have changed. So now same thing. If it is root equal to null, then change the height, and if it is null, then this height would have changed to 0, and then return 1. Otherwise, then calculate then call recursively for the left and pass the pointer to the left LH variable which you initialized, and simply pass the pointer to right integer which you initialized. And you cannot simply pass LH and RH. You have to pass a pointer to these two. Now, after passing the pointer, we can expect that this value LH and RH would have changed from 0 to something. Using those two values, I can calculate the current height as well. This is like calculating current height using the height of left side child and using the height of right side child, and setting into the pointer which I set the value at the pointer which was passed to me, and I am setting star height and not just height. So this is setting also, and then simply return. So all solutions which I gave are kind of, not all, the last two solutions are similar, the C and Java. That's the only difference. This is C solution where we are passing a pointer to the height variable instead of just the height variable, and here we're passing a property. And what is the benefit of calling property only? Because this is a common question which will be asked to you in multiple other ways. and you'll have to do same thing. Instead of just calculating the height, current height, this is current height, you'll have to do something current, some property. So it's better I gave you a generic solution. You can use this kind of generic solution, like keep a create a property class with variables like height, variables like something else. I don't remember right now, but some other property which will be calculated before returning true and false, before returning the actual value. Those property will have to be set using the property which was assumed to be set by the left and right. If you still haven't got, we'll have to move next. We'll have to do this separately, Vasant or anyone.
Yeah, can you tell me more questions, like what all other questions where we will use the same thing?
अभी याद नहीं आ रहा मेरे दिमाग में अभी कौन सा क्वेश्चन है.
ओके चलेगा. नेक्स्ट टाइम अगर उसका नंबर ऑफ क्वेश्चंस वो अगर लाइन अप रहे तो.
Is height balance is अभी याद नहीं आ रहा, मैं बात बताऊंगा. ठीक है,
चलेगा.
ठीक है. Next question. I am moving on to the next question, which is again the question from the previous class only, which we haven't solved yet, and this is also very widely very frequently asked question. Is BST given a tree, the root node of the tree, you have to tell whether it's a BST or not, return boolean. First of all, define what is BST. Someone, what is BST? Give a proper definition without using anything. Yes.
Left node should be less than the root, and right node should be greater than the root.
Try to give a even more detailed definition.
Praveen, that last question, right? Can you share me the code? Once you're I got clear idea now, but I need that code as well.
Yeah.
The last one.
So
this one as well as that object one. I need object one because in Java we need to show through object.
Yeah, we have both the code. I have both the pseudo code. They're not properly encoded. They might have some problem. You can change.
If you can upload the video after the class so that we can go through again.
And finally, we need this workspace also if possible, because you don't clear anything. Just it makes sense because if I go through this workspace.
I'm pasting it in Word. I do paste everything in Word. No, do I miss it?
No Word, but try to give all this code whatever you wrote it here.
I'll paste it.
Means after the class itself, you can send it to us.
Okay. After the class itself, I'll paste this all the line which I've written into the doc which I've said. The video will take half an hour to generate, and then it takes some time to upload. So that's why sometimes it takes. But code, everything which I write, I'll paste in the doc. Should you have the doc which I use?
Yeah.
All the people. I'll share the link once again. Do not have it. Just a minute.
We have the link.
Coming back. Is BST. So definition. Let me give a very clear definition. So you should also be thinking that way only. So what is BST? BST is a binary tree in which all the nodes have satisfied this property. What this property? And this property should be satisfied all the nodes, not just the root node, but all the nodes, not just any single node, but all the nodes. The property is the value of the node should be less than all the value in the left subtree, and should be more than all the value in left subtree, and should be less than all the value in the right subtree.
Right.
Value of the node, value of the root or the node should be more than the value of all the nodes in the left subtree, and should be less than value of all the nodes in the right subtree, or equal to whatever. That is what BST is. So yes, it will now. By the way, this question, if you do it the previous way, like you go to each node and you check at each this property for each node, and then you do it recursively for each node. Will that be working here?
Yes.
So it's checking all the conditions.
Again, so this is order n square is very default solution, very brute force approach. You go to each node and then you check the value of the that node. Is it less than the left? Is it more than the left? Is it less than the right? And then you do it for all the nodes of the. Okay, tell me. Think again. Take your time and think again.
If we can check one by one, like brute force.
Okay.
Like if root dot left dot data less than root dot data, then
So what you'll have to do is if root dot you'll first of all you'll do it for recursively for all of them. Let me write a brute force approach for you. So what we have to do is we have to first is if boolean left is equal to is BST of root dot left and boolean right is equal to is BST of root dot right. And now these two recursion will not be enough. We'll have to check how to beat.
You need to check it in the middle, left and right.
Okay, I have not yet implemented check value, but do you get what I'm trying to do here? Brute force approach. What it has to do is it has to check the value like that root's value is less than all the value in the left subtree, and then okay, I mean check greater, check less. So this is like two other methods, which simply what does is it goes to complete subtree and then checks whether the value of that whole all the value in that subtree is less or not or greater or not. Okay, there are two methods which you can implement yourself, and we know that with these two methods, that check greater and check lesser, what it does is it compares the value of the root with all the value in the root second variable to subtree, and it similarly check lesser is what it takes the root value and compares with the, or we can simply pass root dot value only by to pass root dot value So it simply checks if there is any value in this tree, if there is any value in this tree which is greater or which is lesser. So these two methods will help us if there is so check greater we call for the value with left. So we have to just ensure that root dot value is greater than all the value in the root dot left, and check lesser will check that all the value in the right is more and the value is less. If these two satisfied, then only call recursively is BST root dot left, and also call recursively is BST root dot right. Otherwise, false. Is this understandable by you guys? What is happening here?
Yes.
So
root dot value.
yes.
Root dot left dot value.
Root dot left dot
Value.
this check greater.
Yeah.
No, so that's what I don't have to just check compare with the left value and right value. I have to compare with the whole left subtree and with the whole right subtree. That's why part this method I haven't implemented, but what I want to do is I want to traverse the full left subtree, I want to traverse the full right subtree and compare with each and every value. So you can implement that yourself, that check greater and check lesser. And how will that implementation be? I'll check for if root dot if whatever. So let me write this method for you only now. Check greater, it takes some value, and it takes some node. Takes some value and takes some node, and it simply checks if it is greater or not, less or not. So if value is less than node dot value, return false. Otherwise, return check greater the same value but with root dot left and for the same value with left dot child. So I want to do this. This is that pre-order traversal and what this is like pre-order traversal. Yes, this is like pre-order traversal. Have you heard of pre-order traversal?
Yeah.
I'll discuss that as well. So
Yeah.
this is what is greater, and then we have one more thing. If node is equal to none. Okay. So this is check greater. Similarly, we can implement check lesser also. So this is one full recursive method which is called at every node for our isBST. Okay, this is simple to understand method which I have written. Even this isBST and isBST. Now, this is a brute force approach.
Praveen, here my question. Yeah, here my question is why we are doing recursion in check greater, because anyhow we are doing it in isBST, right? So I'm thinking we no need to do. I think here just we can check true or false. That's it. Again, it is like we are. So in the check greater, what we can do, just we need to check whether it is true or false. Why we are doing anyhow in isBST, right? It is going to do recursion like root dot left, root dot left, root dot left means it is keep on going to leaf node. Again, it is root dot right also doing the same thing. Why we are do it again in the check greater? Again, it is like we are repeating twice. I'm thinking.
No, so
otherwise we have to do.
Forget about this. You tell me how will you do? I mean, don't tell me the best way. Just tell me brute force approach. What do you want to do? Tell me in terms of English only. I'll write here what you want to do. So you are at the root node. What do you want to do now? How will you do? In terms of English, tell me what will do. If so, you want to what is brute force approach? The brute force approach is that my current node's value, which is this, should be less than all the value in the left subtree. So it should be greater than all the value in the. So this is my way. This is how I can check. I don't know any other way. Right now, my brute force would be I'll just traverse complete deeply inside the tree and then check with each and every one. This is some way to check. I don't know how can we implement this efficiently, but this is I want to do. Okay. Now I want to do one more thing, that my current value should be less than all the value in the right subtree, and this is the value I want to compare with all the value in the left subtree. This is how I point to my right subtree. Okay. Now if these two things can be done in some other better algorithm, but I have to do this. There's no other way I can ignore this, because I want to ensure that my value is less than and more than. Once I've decided these two, I can say that that node is proper, but it might happen that internal the left subtree and the right subtree might have some problems. So I'll do this even for left subtree and right subtree as well. That's what I'm doing. So which part of this code you think can be skipped?
Yeah, the below one. Can you go to check greater? Can you come down? Yeah, here. Okay, first, if statements are true, what you're doing, but why we are doing it in? So what I'm thinking, okay, if node equal to null, return true, or if value less than node dot value, return true, else return false. Here is false, else true.
This is what you want to do?
Yeah. Because in above is BST, right? Anyway, we are doing recursion. Again, we are going down.
So what you just checked by doing this, checked that my current value is more than left. That's it. You just check my left value is more than correct. This is the only thing you checked.
Yes, okay. Correct.
And you assumed that this left internal recursive call will handle for itself as well as it will handle for myself. How can you assume that? Let me give you example.
Yeah, but you can write some tree.
Yes, I'm writing example. So this was suppose 5. Only. This was 6, and something else. Suppose, and this was 3, and suppose here we had 7, but not visible. No, it's visible. This is 2. Suppose this was 10. Now, if you see this example and you do what you have done, so you will just check you just check greater. This will just check whether my left value is. So this will be true, and hence you will, and this will also done true, and hence you will call for 3. Hence you will call for 3. Okay. Now this 3 will just check my left and my right. This will be also think it is correct, and this will call recursively for this, and this will call recursively for this, and then both everything will be done true. Where have we captured that 6 is also more than 7? We have not. If you don't do that, if you don't check recursively for all the values, then how will you capture this thing that 6 is less than 7? And it cannot happen. 7 cannot be happening here. This is the wrong example.
Yeah, just I'm thinking how you did this. Okay, can you come down to that check greater? Just the last line.
Yes.
Greater not left.
I have to ensure that every node value is not just less more than the left node. It is more than all the value in subtree, not just one, but all of them. And I cannot expect the recursion to do that. This recursion, okay, sorry, we can, all those things we can implement smartly, but this is a brute force approach. And this is not doing that. I mean, you might have to change something to do that, but this brute approach is not doing that. This brute force approach is simply taking care of itself. That I will ensure that I am this recursion called that I am balanced. Sorry, I am BST, and this recursion I am BST. You take care of yourself. This is what is happening in this method with this implementation. You might have to make it a little bit better. That is what the main question is. How, but this is brute force. This is a working brute force approach.
Okay.
This is order n square.
Okay, can you scroll down a little bit? I wanted to see the last line. Come down. Okay, here we need to pass root, right? Root, I think one of the root, I think, or root dot left.
I have passed some value and root dot left. Some value and root dot left. So check greater, what it does, check greater is it takes a value, some data and a node and checks whether the value in that tree is like whether this value is greater than all the values in that. This is simple method. The function of this method is someone is okay. So the function of this check greater is to ensure that the value is greater than all the value in this subtree, which is rooted at node. That's the function of this. So for this to work, it has to check with the child. It has to first check at that node. So that's why it checks at that node whether I am greater or not. If it is not, then return false that at that point only. You don't have to go deeper. Otherwise, if I'm greater, then just check for you're done with that node, but then check for children as well. So this method has to do that. This method, depending on this method's output only, I can go ahead. Yes, I am greater than all the people on the left subtree, and I'm less than all the node in the right subtree. Hence, I can now relax for myself. I'll go and tell you, you take care of your left node, you take care of yourself, right node you take care of. At least I am done for myself. This is what this code looks like. Okay, I'll paste this.
Yeah, yes. Just 1 second. Yeah, you can paste it. I understand this one properly, but you can paste it.
Yeah, I'll paste again. Yes. So this is a brute force approach which takes order n square. We have to improve, and I do not think you can do this improvement without my help in just some time. So I would expect again you to do this after the class. It's already 2:07 now. So what you have, I'll give you a hint by the way. We did only 2 questions, but this is very, very important. These are very 2 important questions. These 2 are very.
So this is n square, right? Because we are. This is n square, right?
Yes,
the
this is n square.
Yeah.
This is n square, yes.
Because taking one value and checking all this child, taking one value and checking all its child, so it takes n square.
Yes. Yes. So you have to improve this. You have to by improve, I mean you have to do in order n only, and I have already done for you is balanced height by this method. That following approach is height balanced. That might not work here exactly, but you have to think something else. I'll give you one hint. So what a hint is, see, think top down. What I do in top down is, in these cases we were doing bottom up, like we were depending on the child, we were depending on the child to decide for the current node. For this node to be height balanced, we were depending upon the child. So until unless our root node leaf node has been solved, I cannot solve for root node, the topmost node. So I'm depending upon children for my decision. So this is like bottom up approach. The code we have written is first solve the bottom and then solve for the top. This is top bottom, not bottom top. This is top to bottom. This solution will be top to bottom. I'll just solve for myself. Again, this is that thing only. By the this implementation is that thing. I just solve for myself and then I call it recursively for children. I don't. My children doesn't care about my children, and I don't depend on my children. By the way, I mean. Whole solution, of course, it works on all of them, the current node as well as the children. But calculation of this that is my node BST? Is my node satisfying is current node satisfying BST property? Is current node satisfying property? Does not depend on children's output. Here, is the current node height balanced or not? Depends on the output of left subtree and right subtree. This is one difference between this question and that question. Hence, the above thing cannot be replicated. Although I've told you that there are going to be many questions which similar to this question not similar. So don't have to spend time solving this way. There is some other way that is again top to top. So again, bottom up and top down are two different approaches you will be getting in different questions. So these two are like again approaches, top to down approach and bottom to up approach, and depending upon kind of question you'll have to think, should I go top to bottom or bottom to up? This is a generic question for top to bottom, and this is a generic question for bottom to top, whatever, bottom up, whatever. So now another hint here is, one hint is top to bottom, another hint here is your root can be any value. Your root can be any value. It's not bound to be any less than or something. I mean, of course, it is bound to be that it has to satisfy the property of left and right child, but it can be any value in the range minus infinity to infinity. But the moment you go down, left or right, the value of that is constrained. The value of that node cannot be greater than my root. It cannot be less than something else. I mean, less than also something. So now we are putting constraint on the children depending upon the parent's value. So if I have if my parent is okay, if the current node which is parent node, if that is BST, then I can go ahead for my children node. Then I can go ahead with children node, and I can use the value of parent to decide whether children is BST or not. This is the hint. Use the parent's value as limitation for children. Use so what will the limitation for the parent, the root node? It will be minus infinity to infinity. The limitation for a root node will be minus infinity to infinity. It can be anything minus infinity to infinity. But the moment you go deeper, that limitation, the boundary of the left child and subchild is now restricted. It cannot be minus infinity to infinity. It has to be something depending upon the value of the root. That is good enough hint. Now you can start thinking on, and you can do it after the class. We did only 2 questions today. I had planned a lot of these 3 traversals, but we'll do it in next class now. Anything else you want to ask? So I'll paste this right now only before we do anything. You can ask your question meanwhile.
Praveen, I was thinking for that traversal.
What? Louder?
I was thinking for the traversal, in order traversal.
In order traversal. For what? For this isBST?
Yeah.
In order traversal for isBST. I am not sure.
Array is sorted on ascending. Because left, root and right.
Yes, you are correct. So there is one good solution which has been given by Subhadeep. Can you just, Subhadeep, repeat what you just said loudly and boldly, what you just said?
Yeah, if we can traverse the tree using in-order traversal. So how the in-order traversal works? So first it will print the left node, then the middle node, then the right node. So after traversal, we can check the array, whatever we can store it. If it is like ascending order, then it is BST.
Yes. So what he's saying, I don't have to do all this tough thing. I'll just do in order traversal. I'll store the value in an array, and once that array is created, I know the in order traversal of a BST. In order traversal of a BST is always sorted. So if my array is sorted, then it means it is a BST. So it's like storing the value of the tree into an array and then deciding whether it's a BST or not, because BST is always sorted. Okay, this is correct. This will work, but I don't want to use the extra space and all. But that is correct.
Okay.
Others, do you understand in order traversal and why is in order traversal sorted?
Yes.
Okay. Okay, then. That is one solution, but I don't expect that. I'm not expecting that. I'm expecting something else. So that's enough from me now. If you have any other question, you can ask. Otherwise, I'll stop the class.
So are we going to have class tomorrow also or
Tomorrow
Friday?
is Friday. Yes, tomorrow
Tomorrow
also
is
the class.
Thursday.
Tomorrow is Thursday. No, then no. We need to have one more class. We have two more class by the way. So this is a regular class by the way. This is a regular class.
Okay.
This is a regular class. We have to have two extra classes, which is not on which is on Friday. Hello.
Yes.
Yeah. So we'll do the extra class on either on Saturday and Sunday. Not these. We will not disturb this MWF. Anyways, tomorrow Thursday we'll not do the class tomorrow. We'll do the class, or we can do class tomorrow. Let me
Yeah, we
think.
can do it
Let's do it
tomorrow.
tomorrow. Yeah, let's do it tomorrow only then.
Yeah.
Because we haven't studied a lot of things today, and I have lots of questions already prepared for. I thought we'll cover. So I have material prepared, so we can do it tomorrow. Okay.
Can we meet it in morning, like morning class?
Tomorrow morning. Is there any problem?
Because I have like interview tomorrow, day after tomorrow, and next week Thursday also.
So
Yeah, so a
tomorrow
lot of
morning, what time you want? Any
So
slot?
I have my interview at 1, so we can meet it like in the evening itself today. So tomorrow, like morning IST.
Uh-huh. So Subhadeep, will you be able to attend at tomorrow morning?
Which time?
Huh?
Which time?
So let's try for 8. If we get up early, good. Otherwise, 9 is sure. Okay.
Nine,
Yeah.
nine,
Thing is,
nine,
thing is,
9:30.
I have to come to office at my flat. That I was sleeping. I can't. So I have to come to office. So we'll try for 8. Otherwise, 9 is for sure. Okay.
Yeah, just confirm on WhatsApp.
Nine, nine,
Yeah. Morning, I wake up. I'll confirm what time. Okay.
9 or 9:30.
9:30 नहीं हो पाएगा. I have work also. So 9.
Sir, 12:30
Latest
बज
is
रहा
9.
है.
Dude, I'm in office right now. I'll go home. I'll sleep, wake up, come back to office. So you have to manage.
Okay.
Okay.
Okay. Thank you.
So bye.
Okay. Bye.
Bye.